right, we're going to work on doing some practice with naming ionic compounds. All right, let's review some rules for naming compounds. We take the symbol and we convert the symbol to its name, which we get from the periodic table. So your metal is always written first and you don't change the name. And you write the non-metal second. And you change the ending, which is usually INE, to IDE. So fluorine would become fluoride. There's a couple things that you need to know. First is if you have a transition metal, you will write the charge of the transition metals in parentheses after the metal, and you'll write this in Roman numerals. So you won't write a plus or minus, you'll just write the number of the charge because we know that metals are always positive charge. If you have a polyatomic ion present, these are typically but not always going to be in the non-metal position. The polyatomics you are not going to change the end of, so do not change the ending. You'll just name them as is. Okay, after we've identified that this is in fact a metal bonded to a non-metal, I can go ahead and use my ionic naming rules. So looking at the periodic table, K is potassium, and potassium is my metal. So I don't change the ending, I just name it as is. Cl stands for chlorine, so I'm going to change the ending of chlorine to chloride. So the name of KCl is potassium chloride. All right, so I have magnesium and I have the polyatomic ion hydroxide. This is an ionic bond because I have a metal and a non-metal, but we do have something kind of funny going on. Anytime you see more than 2 capital letters, you know that you have a polyatomic ion present. So it's either going to be MgO or OH, and I know that OH is a polyatomic ion. So I'm going to name that as is and not change the ending. So let's name Mg first, which looking at my periodic table, that is magnesium. And we'll name our polyatomic ion second, and we don't change the ending. And OH is hydroxide. So MgOH2 is magnesium hydroxide. All right, so we have another ionic compound. We have a metal and a non-metal coming together in a bond. This time our metal is iron, and iron is a transition metal, which means I'm going to need to put the charge in parentheses in Roman numerals. I'm just going to leave that as a space right there, and I'm going to finish naming. So sulfur gets changed to sulfide. Another thing to keep in mind when you're trying to figure out if I'm talking about iron 2 or iron 3 is to reverse the subscript. So this subscript originally was the charge of iron, and I dropped and swapped that. So this iron has a charge of 3, so I put in my Roman numerals that it is in fact iron 3 sulfide. Another option that you have to use is either calling this ferric or ferrous sulfide, and that uses the Latin root, and we always give the IC ending to the higher charge and the OUS to the lower charge. So in terms of iron, this ferric would be a +3 iron and ferrous would be a +2 iron. So because we know we're dealing with iron 3, we could call this ferric sulfide as well, and either of those names would work. All right, in our last example, we are dealing with Pb, which is lead. And lead falls into that funny family where its charge can either be +2 or +4. Because of this, we treat it just like a Roman numeral. So I'm going to leave parentheses so I can figure out what the charge is and put it as a Roman numeral in the name. And I'm noticing that I have more than 2 capital letters. In fact, I have a lot of capital letters. So I know that I must have a polyatomic ion present. CH3CO2 is acetate, And because it's a polyatomic ion, I don't change the name, I just name it as is. I don't change the ending. So now I need to go back and figure out what the charge of lead is. It's either +2 or +4. So I'm going to look to the subscript of my nonmetal because that was dropped down from the charge of my metal. And if there's no number, we assume that is 1. So I'm just going to double check that charge as well to make sure my subscripts weren't reduced. So the charge of lead in this case, we are dealing with lead 4 acetate.